AI is starting to optimize itself at two very different levels: what to research and how to build the systems that do the work. One line of work shows agentic ideation is still mostly local good at recombining existing methods, but surprisingly narrow in scientific search. Another shows software modernization can be made safer and cheaper with graph-based, small model-driven evolution instead of brute force LLM rewriting. And the third pushes skills into a compact, editable form that can improve across models and runtimes. Let's explore the first paper, AI Research Agents Narrow Scientific Exploration. This paper studies AI research agents from AI scientist, research agent, agent laboratory, and a zero-shot baseline as scientific search systems, using 6 LLMs from Qwen, Llama, and Gemma to generate 37,802 valid research ideas from 34,698 papers in ICLR, NeurIPS, and ICML spanning 2019 to 2025. Across 19 citation-defined research areas, the authors find a consistent pattern. AI-generated ideas are more concentrated than human-authored papers, with within-area cosine similarity of 0.82-0.84 versus 0.77 for human papers, and a centroid distance of 0.091 versus 0.121. The ideas also stay closer to the seed literature than later human follow-on work at 0.92 similarity versus 0.88, suggesting local extrapolation rather than broad exploration. To probe impact, the paper matches AI ideas to 2,359 semantically similar human papers and finds those papers receive 50.4 citations on average, below the 54.9 citation, same area baseline by 4.47 citations. Finally, the content analysis shows AI agents mostly recombine methods rather than invent new questions. 85.1% of ideas reuse the seed literature's research question, while only 62.6% reuse the technical method, indicating that current agentic novelty is concentrated at the method combination level rather than at problem discovery. Let's explore the second paper, EvoGraph Hybrid, Directed Graph Evolution Towards Software 3. EvoGraph, from AutoHand AI, proposes hybrid directed graph evolution as a closed-loop modernization system that treats code, build pipelines, documentation, tickets, schemas, logs, and runtime telemetry as one typed directed graph, then mutates that graph with small language model-driven operators and a multi-objective safety gate. The framework combines weight merging, AST patching, documentation sync, build weaving, and cross-language transmutation, while ranking candidates with a contextual bandit and Pareto plus novelty selection. On 7 legacy-style benchmarks, EvoGraph fixed 83% of known security vulnerabilities, translated COBOL to Java with 93% functional equivalence, and kept documentation freshness within 2 minutes. Across multi-language modernization, it reached 96% semantic equivalence on COBOL, .NET, Lisp, CGI, ColdFusion, Legacy Python, and C, while reducing computational cost by 90% versus large language models. The system also cut P95 latency by 40% and featured lead time by 7 times relative to strong baselines, and on 1-2K COBOL programs, its transmutation step reduced manual review edits by 58%. In resource terms, processing 10K lines of code required 1-2 GPU hours and 45 kilowatt hours, compared with 120 GPU hours and 450 kilowatt hours for a GPT-4-based approach, highlighting the paper's central claim that specialized small language models make production-safe software 3-style evolution practical rather than purely aspirational. Let's explore the third paper, SkillOpt Executive Strategy for Self-Evolving Agent Skills. SkillOpt, from Microsoft with collaborators at Shanghai Jiaotong University, Tongji University, and Fudan University, reframes agent skill improvement as a controlled text space optimization problem. A frozen target model executes tasks, while a separate optimizer model edits one reusable skill document through bounded add, delete, replace operations, held out validation gating, rejected edit buffering, and an epoch-wise, slow meta update. Across 6 benchmarks, 7 target models, and 3 execution harnesses, Direct Chat, OpenAI Codex, and Anthropic Claude Code, it is best or tied best in all 52 evaluated cells, outperforming human-written one-shot LLM, Trace2 Skill, TextGrad, GEPA, and EvoSkill skills. On GPT 5.5, the average gain over no skill is plus 23.5 points in direct chat, plus 24.8 inches codex, and plus 19.1 inches Claude code, with large procedural gains such as 41.8 to 80.7 on Spreadsheet Bench, 33.7 to 3247 on Office QA, and 34.9 to 99.7 on Live Mathematician Bench. The learned artifacts stay compact, only 379 to 1,995 tokens, and require just 1 to 4 accepted edits. Transfer is also a central result. A codex-trained Spreadsheet Bench skill transfers to Claude Code with a plus 59 7-point gain. And a cross-benchmark Olympiad Bench skill improves OmniMath by plus 3.7 on GPT 5.4. Ablations show that removing the rejected edit buffer drops Spreadsheet Bench from 77.5 to 72.9, while removing both meta skill and slow update collapses it to 55, confirming that skill op stability comes from validation-gated, bounded updates rather than unconstrained rewriting. That's a wrap on today's AI paper highlights. Thanks for watching.